Find a unit normal vector for the function f of x comma y equals 1/2 x cubed at the point 2, negative 3, 4. Recall, a unit normal vector is a vector with a magnitude of 1 or length of 1 and perpendicular to the surface. To begin, we need to determine big F of x comma y comma z, which equals f of x comma y minus z equals 0. Once we do this, the unit normal vector n is equal to the gradient of big F divided by the magnitude of the gradient of big F at the point 2, negative 3, 4. To begin, big F of x comma y comma z again is equal to f of x comma y minus z equals 0, which in our case is 1/2 x cubed minus z equals 0. And now we need to determine the gradient of big F, which is the vector function in which the x component is the partial of big F with respect to x, the y component is the partial of big F with respect to y, and the z component is the partial of big F with respect to z. To determine the partial of big F with respect to x, we treat y and z as constants and differentiate with respect to x. The partial of big F with respect to x is equal to the derivative of 1/2 x cubed with respect to x, which is 3/2 x squared, and then minus the derivative of z with respect to x, because we treat z as a constant, the derivative of z with respect to x is 0. The y component is the partial of big F with respect to y. To find the partial of big F with respect to y, we treat both x and z as constants and differentiate with respect to y. The partial of big F with respect to y is equal to 0. The z component is equal to the partial of big F with respect to z, which means we differentiate 1/2 x cubed minus z with respect to z, treating x and y as constants. The derivative of 1/2 x cubed with respect to z is 0, and then minus the derivative of z with respect to z is negative 1. And now we need to find the gradient vector at the point 2, negative 3, 4. The gradient of big F at the point 2, negative 3, 4 has an x component of 3/2 times the square of 2, a y component of 0, and a z component of negative 1. Simplifying 3/2 times 4 is 12/2 or 6. The x component is 6, the y component is 0, and the z component is negative 1. And now we'll determine the magnitude of the gradient vector, which equals the square root of the sum of the square of 6, the square of 0, and the square of negative 1, which equals the square root of 37. And now we have the information we need to determine the unit normal vector for the function at the given point. The unit normal vector is equal to the gradient vector 6, 0, negative 1 divided by the magnitude, which is the square root of 37, which indicates the x component is 6 divided by square root of 37, the y component is 0, and the z component is negative 1 divided by the square root of 37. This vector has a magnitude of 1 and is normal or perpendicular to the surface given by f of x comma y. Let's take a look at this graphically. We have the graph of the given surface, and this red vector is a unit normal vector at the point 2, negative 3, 4. This vector has a length of 1 or a magnitude of 1 and is perpendicular to the surface at the point. I hope you found this helpful.